Okay, so we're rolling. So you may want to stick with it. This is going to be a little long one, and I'm starting off on the wrong slide, so no attention to that slide. Let's go back to this one. It's very much the same, but a little larger. So we're going to try to find the area underneath the curve. Okay, find the area underneath the curve, and this is the curve. It's y equals x, or f of x equals negative x squared plus 7. We're just going to look at the area between 0 and 1. We're going to try to find that area. And we're going to do it with just 5 rectangles for right now. So we're going to put a rectangle there, and we're going to put a rectangle there, and these are going to be a little bit off, but that's okay, you'll get the idea. And then we're going to put one there, and then we're going to put one there, and then pay no attention to the fact that they're down below the thing, we're just looking at the part above. And then we're going to put one there, and we're going to assume that that fills in all the space. Pretty close. There's a little overlap, but you get the general idea. Okay, so we're going to use 5 rectangles. We're going to figure out the area of each one of those rectangles, and then we're going to add up those, and we're going to see what happens. Okay, right away you could probably tell that it's not going to be completely accurate because we've got some gaps here, and there. Okay, so let's continue. See how this works. All right, so all of my rectangles, since I've got 5 rectangles, and they're between 0 and 1, all of my rectangles are 1/5 wide. Okay? The height of my first rectangle, okay, right here, the height of my rectangle, it's inscribed, is right there. Okay, so this is at 1/5. So the height of my rectangle is whatever the f of 1/5 is. Okay? So the area of this first rectangle is 1/5 times the f of 1/5. Okay? So generally speaking, if I went to the second rectangle, nothing really would change. My width would be the same, but my height would now be the f of 2/5 because my second rectangle edge would be at 2/5, and then the next one would be at 3/5, and then 4/5, and then finally 5/5. Okay, so if I'm going to do all the rectangles, I'm going to add up rectangle 1 plus rectangle 2 plus rectangle 3 plus rectangle 4 plus rectangle 5. And I'm going to do that in a little bit of a sneaky way using some of this summation stuff. Okay? I'm going to write the sum from I equals 1 to 5 of my height, which is the f of, now watch this, I over 5 times 1/5. Now the f of I over 5, because the first rectangle number 1 is at 1/5, rectangle number 2 is 2/5, 3/5, 4/5, 5/5. So our counting from I goes 1 to 5, 1 to 5, and so it works like that. Okay? So we're going to continue through this. We got 1/5, which is just a constant, so we can bring that out in front of the summation notation. And from I equals 1 to 5. The f of I over 5, that just means we take I over 5 and put it in where x was. So we get negative I over 5 squared plus 7. Okay? So we're just adding up those 5 particular times. Now we've got our formulas for the sum of the i's and the sum, so let's actually have my head of myself. 1/5, the sum from I equals 1 to 5 of negative I squared over 25 plus 7. Okay? And so what we're going to end up then doing, let's see if we can make this work out, it's going to be 1/5, big bracket, negative 1/25, sum of the I squareds, plus the sum of the 7s. Okay? In both cases we're going from I equals 1 to 5. I equals 1 to 5. Okay? And so we can probably see what we can do. We got 1/5 of, that's a really lousy 5. Let's see if we can fix that. 1/5 of negative 1/25 of, let's see, the sum of the I squareds is n times n plus 1 times 2n plus 1 over 6 plus the sum of the 7s is 7n. Okay? And in this case, n is 5. And so we can probably work our way through this relatively okayly. Okayly is such. So then from here, we carry on further. negative 1/25th. And this is where we can plug the 5 actually in. N equals 5 just to make it, because we're just calculating. So it becomes 5 times 6 times 11, thank you, Java, divided by 6 plus 7 times 5. Okay, and we'll do a little calculation. We can cancel the 6's over. That's nice. We can cancel one of those 5's with that 5. And so then if we go just a little further, and I guess I'll extend it a little further on. Let's see, I've got on the top, I've got negative 11 over 25, 5 times 5, plus, that's really lousy 5, plus 35 divided, so basically plus 7. Okay? So that 5 and that 5 are going to cancel each other, so we've got that. Then we just need to turn that into a decimally sort of number, and I think if I do the calculations real quick, negative 11 divided by 25, this plus 7, and I end up with 6.56. 6.56, and then we're able to move on. So that's the area, and we said earlier that it's not going to be accurate because we've got these little gaps in the, I don't want that, I want this. We've got these little gaps showing up all along the edges that aren't going to be quite so accurate. Okay? So what we're going to do is we're going to say, well, what happens if we circumscribe the rectangles? What happens if my rectangles, instead of being inside, are now outside? So, ooh, what did I do? I want a pen. I want a pen. I want a blue pen. My rectangles are now outside, so I've got a rectangle there. I'm going really big with them just for dramatic effect. I've got a rectangle there. I've got a rectangle, they're awful. I've got one there, and there, and so forth and so on. And you can see that in this case, I'm going to get too much area as I work my way through this. So, we're going to do the same sort of situation, but instead of the, well, the only real difference is I'm going to do the sum, still 5 rectangles from I equals 1 to 5. It's still going to be the height, the width's going to be a fifth, but the difference is the height of this first rectangle is really the f of 0. Okay, and this one's the f of 1/5. Okay, so I'm going to be doing the f of I minus 1. The f of I minus 1, that was really awful. Okay, times 1/5. And I can go through and I can do that whole thing that we just did on the last problem. You know, all this kind of work here with all the summation stuff. And I'm going to end up with an answer that's too big, right? Okay, and so we probably have heard before that the way to get to a more accurate answer is to have more and more rectangles, right? So if I do this, okay, I end up that, you know, the circumscribed in this case, I get too big an answer. For the inscribed to get too small an answer, and for the area someplace in between. So the answer isn't to average the two numbers together. The answer is to get more rectangles. As I get more rectangles, the inscribed rectangles become about the same as the circumscribed rectangles, which become the area. Okay, because as I get more and more, they just pretty much bounce around to be the same sort of rectangle. Okay, so what we're looking at is we're going to be looking at, well, what happens as n gets really, really, really big as we move through this situation here. Okay, so we got some formulas. Area is the limit as n approaches infinity of the sum from I equals 1 to n of the f of c sub I times delta x. Delta x is just the difference between my two endpoints divided by n, which is the number of boxes we have, and we know n is going to get really, really, really big. Okay, c sub I is just my endpoint plus I times delta x, and that'll sort of make sense as we work through a couple of these problems. Let me do it for time here, so that was a little long one. Oh, we're fine. 8.5 minutes. Great. Moving onward. All right, so first thing we need to figure out is what's delta x. Delta x is b minus a over n, so it's 1 minus 0 over n, which is just 1 over n. Okay? So my area is the limit as n approaches infinity of the sum from I equals 1 to n of the f of c sub I. So c sub I in this case is going to be 0 plus I over n times delta x, which is 1 over n. That's a 0, right? 0 plus I over n. Because we said it's it's this. Let me just go back and show you where that is. Okay, so it's I times delta x. Delta x is 1 over n, so I is just the piece there. Okay, so we've got, and the 0 is just the 0. We're going to ignore the 0 in just a few seconds, so as we work through. So now we got to figure out what's the f of I over n. So we plug I over n into this little thing here. So there's a lot of writing. It's the sum of the f, so it's I over n squared plus 2. That whole thing is multiplied by 1 over n. And we're still taking the limit as n approaches infinity, and I get a little sloppy with writing that down, but you get the idea. Okay, so now we've got to go a little further. The 1 over n is just sort of a constant, so we're going to pull that out in front. So we're looking at the limit as n approaches infinity of 1 over n times the sum of I squared over n squared plus 2. Okay? So let's break that into a couple of pieces. The limit as n approaches infinity of 1 over n times 1 over n squared times the sum of the I squareds. And what I'm trying to do is break this into pieces so that I can use some of the formulas that we have from our summation notation that we have on that sheet that I've given you already, I think. Okay? Or will have given you by the time you see this video. I'm predicting into the future. It's freaky. All right, so 1 over n. Oops, still doing the limit. Okay, pretend that says that. Bracket 1 over n squared. Formula for the sum of the I squared, same as it was last time. N times n plus 1 times 2n plus 1 over 6 plus the sum of the 2's, 2n. Okay? So now let's distribute that 1 over n back in there. So we're looking at the limit as n approaches infinity of, let's see, this becomes, let's see, let's see, it becomes 1 over n cubed times n plus 1 times 2n plus 1 over 6 plus 2n over x. I'm distributing that to both terms. Okay? Let's see. Here we get boom, boom. That cancels out, right? Here, those cancel out. Okay? Here's a little one of those things that every single time it's the same thing. Okay, every time we multiply n plus 1 by 2n plus 1, it turns out to be 2n squared plus 3n plus 1. Every time. Okay, so if you have that sort of in your brain, you don't have to every time go through and go first, down, sign, in, sign, it's that. Okay? All right, so what we end up with as we move along here, we get the limit as n approaches infinity of 2n squared plus 3n plus 1 over n squared plus 2. So if you remember, the limit of 2n squared, see, remember it's limits at infinity? As we get there, these have the same degree. So this whole thing just sugars out to 2. And this thing here sugars out to 2. And so we're left with the difficult question, what's 2 plus 2? It's 4. And so the area under the curve as we work our way through this is 4. Okay? All right, let's see. Do I have time to get another one in here? Where are we at? 12:53. Doubtful. Let's see what we do. Oh, yeah, especially that one. So we may start class off with this one here. If you want to wrestle with this for a little bit, maybe we'll get the setup going and see how you do on it. First of all, delta x is 2 minus 0 over n. Okay? So my formula that I'm going to do is the limit as n approaches infinity of, let's see, the sum, it's a lousy sum, from I equals 1 to n, of the f of, again, it's 0, so I'm just going to make that 2i over n, because it's like 0 plus 2i over n, times 2 over n. It's 2 minus 0. Okay, so the f of c sub I times delta x. And then we would probably go through and we plug 2i over n in there, so we're going to end up with the sum of, let's see, 2 times 2i over n minus 2i over n cubed plus 3. All of that multiplied by 2 over n. Okay, see if you can take it from there. See how far you get. We'll pick up on that first thing when you get into class tomorrow, or second thing or third thing, someplace before we get rolling on these particular things. So there's the thing. Oops, there's that. So it's like 3 problems that we're going to work on in class tomorrow, so it's not a whole lot, but obviously these take a little while to get going. So take this from here. We'll see what we can do. This is difficult stuff, so stick with it, because, you know, it's going to take a little bit, but you'll get it. I have faith in you. You have faith in you, and we'll be all set. So if you get questions, ask, and take a stab at that, see where you go. All right. Hey, thanks for watching. We'll see you tomorrow.